Hello everyone, welcome to Trident, threat recognition and intelligent detection for networks. Modern web applications face sophisticated attacks like zero-day exploits, bot-driven intrusions, and API abuse. Traditional web application firewalls rely on signature-based detection. They can only block known attack patterns. But what about attacks with no known signature? What about novel exploitation techniques that bypass static rules? Trident solves this by combining traditional rule-based filtering with intelligent machine learning-driven anomaly detection. Let me walk you through our architecture. We have a React-based dashboard that provides real-time monitoring, traffic visualization, and alert management. Our fast API backend handles all API requests, manages the database, and orchestrates the detection pipeline. The ML engine is the heart of Trident. It performs behavioral analysis, feature extraction, and anomaly detection using an ensemble of machine learning models. Let's dive into our technology stack. Backend, Python 3.11 with fast API framework, SQL Alchemy ORM for database management, Pydantic for data validation, ML engine, PyTorch for neural network training, scikit-learn for traditional ML algorithms, NumPy and Pandas for data processing, frontend, React 18 with Vite, build tool, Tailwind CSS for styling, recharts for data visualizations. Now, the ML structure. This is where Trident truly shines. After the data ingestion from the site to our database, we extract 40 plus engineered features from every request, including request rate and frequency patterns, payload entropy analysis, URL path structure, time-based behavioral patterns, historical baseline comparisons. Then we use an ensemble detection approach, combining isolation forest, an unsupervised tree-based algorithm that identifies statistical outliers. It's excellent at detecting unusual patterns in high-dimensional data. Autoencoder neural network. This learns to compress and reconstruct normal traffic patterns. When it encounters an attack, the reconstruction error is high. That's our anomaly signal. Weighted ensemble. We combine both models' predictions for robust detection that catches what either model alone might miss. And then final decisions. Now let's see Trident in action. I'll walk you through each section of our dashboard. This is the main dashboard. At a glance, you can see system health status, showing backend and ML models are healthy. Total alerts generated by our ML system. Pending security recommendations awaiting approval. Traffic volume with a 24-hour sparkline chart. Anomaly rate, the percentage of traffic flagged as suspicious, and recent alerts with severity indicators. The traffic overview page shows all incoming network requests. Notice the distribution by HTTP method, get, post, put, delete, and status codes. We can filter by IP, method, or time range. Here's our alerts management page. Each alert shows severity level, critical, high, medium, or low. The triggering IP address and endpoint anomaly, score from 0 to 1. Risk score from 0 to 100. The recommendations page is where ML insights become actionable. Trident automatically generates security rules in multiple formats. JSON for rate limiting, mod security rules for pattern matching. Administrators can approve or reject each recommendation. Approved rules can be deployed directly to your WAF. Finally, the analytics page shows model performance metrics, detection accuracy over time, false positive rates, severity distribution, response time statistics. This transparency ensures security teams can trust and verify the ML system's decisions. Now for the exciting part, let's see Trident detect attacks in real time. This is our test e-commerce application running on port 3001. It simulates a real website with products, cart, and user sections. Every request from this site is logged to Trident. On the right, you can see the request monitor updating live with every request. Watch. I'm browsing products. Notice the requests appear with green, low-risk indicators. The ML model correctly identifies this as normal behavior. Now let's simulate an SQL injection attack. Boom. See that? The request immediately appears in red as critical risk. Our alert count just increased. The anomaly score is high because the URL contains SQL keywords like union select. The payload pattern deviates from our learned baseline. The request entropy is abnormal. Let's check the alert. Here it is. High severity anomaly score, 0.78. The ML explanation shows suspicious SQL keywords detected. Payload entropy exceeds baseline by 3.2 standard deviations. Let me try an XSS attack. Detected. Script tags in the payload triggered our pattern detection. Notice how Trident generated a recommendation to block similar patterns. This entire detection happens in under 1 second. Real-time, production-ready performance. To summarize, Trident delivers zero-day detection, catching unknown attacks through behavioral analysis, sub-second latency, real-time detection suitable for production, explainable AI, full transparency on why each alert was generated, WAF-ready rules, direct integration with mod security and cloud WAFS, continuous learning, feedback loops that improve accuracy over time. For future enhancements, we plan to add TLS traffic decryption module, Kubernetes sidecar deployment mode, transfer learning for domain-specific attacks. Thank you for watching. Trident, protecting networks through intelligent anomaly detection. Check out our GitHub repository for the complete source code and documentation.